Good evening, Preetham. What about others? Where are they? How many were there in previous class? Sorry?
5 to 6.
5 students were there.
Yeah.
Okay. Time started now. It's 5. Everyone should join, correct? What happened? Be comfortable. Okay. Am I audible? You can show thumbs as well, thumbs up as well. It's fine. Okay. If your speaker is not working, you can show thumb. Okay. So let everyone join by themselves whenever they will join. If they ask me to repeat, I'll repeat. I don't want to waste your time. Okay. Shall I start? Show thumbs. Okay, fine. No issues. I'll start now. I think yesterday we have discussed about the empirical formula and the molecular formula, how to find it out. So I think I gave you one homework question to find it out, find the empirical formula of one of the substance, right?
Yeah.
Have you solved it?
Yeah, it's 3O.
Okay, fine. So I guess that question was this one. Yeah, a student burned the magnesium crucible. Was this question? This already we have solved here, right? Yeah. This one was the question. Calculate the empirical formula for the compound whose molecular formula is C8H8O4 and its empirical formula of weight is 83.
Yeah.
Was this question? No?
Yeah, this one.
I think that the fourth one, an organic compound has an oxygen, right?
Yeah, both of them.
Yeah, fourth question was there. Fine. So both we are going to solve one by one. That won't be a problem. See what is given to you in this. So the question asked to you is, an organic compound has an oxygen 26.24% and the hydrogen is 4.92%. Find its empirical formula, correct? Yeah. So you should know every organic compound have 3 fixed elements in that. Sorry. Which elements would be there? Carbon, hydrogen, and oxygen, correct? But in this question, they gave you only the percentage of oxygen and the hydrogen. Carbon percentage are missing, right? And you need to calculate it, correct?
H3O.
Yeah, so you need to calculate it. How you're going to calculate? Total percentage would be 100, right?
Yeah.
Yes or no?
Yeah.
Yeah, and because of that, what we have to calculate it. Carbon percentage, hydrogen and oxygens are given. So that's why how you're going to calculate this. Sorry, here you can check. Every organic compound contains carbon, right? Oxygen and hydrogen. And as the percentage of oxygen and hydrogen is given, we are going to calculate the percentage of carbon. So how are you going to calculate the percentage of carbon? Is equal to 100 minus summation of percentage of oxygen plus percentage of hydrogen, correct? That is equal to 100 minus 26.24 plus 4.92. Do this, what you will get? 100 minus this addition. 4 and 2, how much? 6, right? 9 and 2 would be 11, carry over 1. That is 5 plus 26. How much? 31, right? Do the subtraction. What would be the answer? 68.84, right? This would be the percentage of carbon. Right, now you got the percentage of carbon. So each percentage you have to consider as a gram, as I told you, correct? Yes or no? Earlier I told you or not? Means whatever percentage are given that you need to convert into grams. It is the second step, right? So the carbon percentage would be what? Carbon would be how many? 68.84 gram. Now hydrogen and the oxygen. Hydrogen would be 4 point how many? 92 gram. And oxygen would be 26.24 gram. Isn't it? Yes. And total would be 100 gram. Correct? Yes. Now you have to calculate the moles of each element, like how many moles of carbon, how many moles of hydrogen, and how many moles of oxygen are present. For that reason, what you have to do, you have to take its atomic mass and you have to divide the percentage. Isn't it? Gram atomic mass you have to take, not only atomic mass, because atomic mass would be in AMU. You have to divide it with its gram atomic mass, because the value which we have taken here, that is into gram. Clear? Fine. Yeah? Yes. So how are you going to calculate it? Moles of carbon is equal to 68.84 gram. This is a given mass, divided its gram atomic mass, that is 12. What would be the value? Please calculate. The same moles of hydrogen would be how many? 4.92 divided by, yes, 1. Because atomic mass of hydrogen is 1. And the moles of another one is what? Oxygen. Percentage is given how much? 26.24 divided by 16. Do this calculation. Hurry up. 5.74. Yes, first one is what? 5.7. 7.74 around it as it's calculated over here. Second one would be 4.92. Calculate the third one. 1.6. 1.64 or 6. Now, which is the less value among this? 1. Three values you got 1, 2, and 3. And that 1.63 is the less. So we are going to divide all this ratio with 1.64. This is our third step, right? Yes or no? Yes. So what you're going to do here? This 5.74 divided by 1.64. Similarly, again 4.92 should be divided by 1.64, and 1.64 should be divided by 1.64. Correct? So this would be 1. These two values you need to calculate. First one is 3.5. First one would be 3.5. Correct? Yes or no? Because this value is near about 1.5, means slightly bigger than 1.5, and this value is slightly near to 6. Correct? Yes or no? So value means like 3.5 we can say. Yeah? Because 1.5's double is nothing but 3, and whatever extra value would be there, that can be divided by the 0.5. Right? So you get here 3.5 value. Now next one is 1.64 when divided by 4.92. What we'll get? How much? 3. Why it is so? Because you can see, yeah, this is 1.64 and here is the value around near to 5. Correct? So here you will get 3. So the second last step of our calculation of empirical formula would be what? You have to convert the fractions into whole number by multiplying it with any of the integer. So here is 3.5. It's a fraction, right? Yes or no? We have to convert it into whole number, and it can be converted into whole number when it gets multiplied by 2 at least. But then when you multiply it by 2, rest all elements also need to be, means whatever value you will get, that should be multiplied by 2. Then only ratio would be same. Correct? Yeah. So you will get what over here? Carbon how many? 3.5 multiplied by 2, that is 7. Right? Now hydrogen how many? 3 2s are 6. Right? And the oxygen would be 2. So your empirical formula would be C7H6O2.
O2.
Clear? Yeah?
Yeah.
Understood?
Yes.
Any query?
No.
Fine. So I request you to write down the next problem which I'm going to give you. Right?
Okay.
Jaswant is there. What happened? Why students are less in this class? Because I got to know that 4 students were there in the previous class.
I'm
Jaswant,
in
where were you?
WhatsApp. It's actually 6:45, so everyone is thinking like that.
6:45 I have wrote.
I'm in WhatsApp. It's written 6:45.
I have WhatsApp about 6:45.
Yes, ma'am.
Oh, I'm sorry. I'm sorry. I'm extremely sorry for that. I thought I have gave 5:45. So do I have to go for that? Is okay. I'm sorry. How come it happened? 5:45 I have supposed to type. Okay, okay. Ah, so only it's happened. I'm sorry, I don't know now what is to be done. Timing confusion. But then now I have text about it, right? Everyone should be aware like class would be happen now 5:45. Okay, no issues. I'm sorry. I'm extremely sorry for that. Okay, no issues. Go for the next question. Question would be this. Can you do that? Check it. Calculate the empirical formula for the compound whose molecular formula is C8H6O4. If it is not visible to you, I will write it here for you. Write down problem first. Calculate the empirical formula of compound whose molecular formula is C8H6O4. This is a molecular formula. Okay. And the empirical weight is given. That is equal to 83. So what you're going to do now? What you have to do? First of all, you have to calculate the molecular weight by using the molecular formula, correct? Yes. Then only you will get the value of N. Because there is a relation in between empirical formula and the molecular formula. Already we have seen it. Correct? So you have to calculate molecular formula, molecular weight. How are you going to calculate molecular weight? By the formula C8H6O4. That is equal to 8 atoms of carbon, that is 12 atomic mass. 6 atoms of hydrogen with atomic mass 1. 4 atoms of oxygen with atomic mass 16. Do this, go for it. What will be the answer? Hurry up, both of you.
166. 166.
Answer would be how much?
166.
166. Just one, have you calculated?
Yes, ma'am. 166.
166. Okay. So this would be AMU. Okay. And when you express into the gram, it becomes 166 grams. Correct? Yeah. What it would be? What it would be? Gram, molar, mass. Correct? Yes?
Yeah.
When we
Yes,
express into gram. And normally it is molecular weight. That is 166. But then what we have to see, we have to calculate the value of N. How are you going to calculate the value of N?
By
Whatever
dividing the
molecular weight, that need to be divided by empirical formula weight. You will get the value of N, right? So N is equal to molecular weight upon empirical weight, which is equal to 166 divided by 83. This is given, right? And 83 twos are 166. So this value would be 2. What would be this value? 2, right? So you get here N, which is 2. Now, how to calculate molecular formula if you know your empirical formula, and even if you know your they ask you to calculate what empirical formula if you know your this one a molecular formula, right? Yes or no? Yeah. So how are you going to calculate? We have this
simplest
molecular
form
formula
divided
is
by
equal to 2 into empirical formula. Already we have learned this, correct? This formula I gave you or not?
yeah.
So you just have to put the values in this. What values you're going to put in this? N value, your molecular formula value, and later it should be divided by just 2. You will get your empirical formula, correct? Yeah?
Yes.
So see what would be the formula now. In this, I'm going to just put the values. Here, molecular formula is C8H6O4, right? Now, value of N is nothing but 2, and here it is empirical formula as it is. So empirical formula is equal to this 2 is multiplied this side. When it moves that side, it becomes divide. Hence, it would be C8H6O4 must be divided by 2. Now, how you are going to do this division? You have to choose this suffix values, and that need to be divided by 2. Understand? Means here C8, this 8 would be divided by 2, it becomes C4. Then H6, this 6 would be divided by 2, it becomes H3. And here O4, this 4 will be divided by 2, it becomes O2. So your empirical formula would be C4H3O2. Got it?
Yes.
Here you can check the answer over here. Correct? Yes?
Yes.
I hope both of you understand it clearly. Right? I'll give you one more problem. And then we'll go to the specific gravity and rest all vapor density kind of things. Fine. Now see here. Go for this problem. This fifth one. Calculate the empirical formula and molecular formula of compound having the following percentage compound. Carbon, hydrogen, and oxygen is given, and even vapor density is given. So what is vapor density? I'll let you know. Actually, I don't want to share the answer. For that reason, I just have to scroll it up and down little. It's visible, no? Problem is visible to you. Just write down the problem. We are going to solve it together. Okay. Preetham, will you please turn off your mic? Actually, it's disturbing a lot. Fine. See, no issues. In the problem, what is given to you? Calculate the empirical formula and molecular formula of compound. They ask you to calculate both empirical formula as well as molecular formula. And the given terms are compound having following percentage composition. They have given the percentage of carbon. Okay. Percentage of carbon is given, that is equal to how much? 26.59. Right? Then the another one is hydrogen. Hydrogen percentage is given 2.22%. Oxygen percentage is given, that will be 71.19%. Okay, and the vapor density is given to you. Vapor density is 45. Fine. Now you might be thinking like, what is the use of vapor density and what is the vapor density first? Correct? Yes or no? Because earlier we have seen the problems with like calculation of empirical formula wherever molecular weight is given, empirical weight is given, or else empirical formula would be given or the molecular formula would be given. This is quite different. Here they have given the percentage of element present into the formula and the vapor density. So what is the density? What is the specific gravity? What is vapor density and how they are connected with the molecular formula, that we have to see first before solving this problem. So shall we go for it? Yes. If you means like, okay, if you're connected with me, if you're listening me, just show the thumb. That would be easy. Okay. Okay, just one. And what about Preetham? You're there with me? Fine. Okay. So we'll move up. Okay. Just write down this problem with you. I'm not going to ask you to write in between. Okay, directly we are going to solve the problem, but then I wanted to explain you the things thoroughly about that. Okay. Vapor density and all here. Yes. Now see this. Specific gravity means what? First of all, we'll see the density. Density, you all of you knows about the density. Density is nothing but what? Mass upon volume, correct? Yes. What is the density? Density is mass upon volume. Please write it down because it's very important somewhere at the another page, not on the page where you're solving this problem. Okay, on another page somewhere you can write down these formulae. 2-3 formulae are there that I'm going to give you. Fine. And that you need to use while solving the problems. So first would be what? Density. Density is equal to mass upon volume. Correct? Now the next is, what do you mean by specific gravity? And another name for the specific gravity is a relative density. Now what is this? Right? So this is what? A specific gravity is commonly thought of as a dimensionless ratio. Why? Because both are gravities. This term is nothing but a ratio of two same units, and both units get cancelled, and hence it is dimensionless. So actually, it should be considered as a ratio of two densities, that of substance of interest A to that of the reference substance in a symbol. When specific gravity means this is a relative density. How we have taken the reference carbon 12 to calculate the atomic masses of rest of element, in a same manner, to calculate this gravity of calculate the density of one substance, one standard substance would be considered, and with comparing with that substance, we calculate the density. And this is nothing but the ratio. Is called as what? Specific gravity, right? And as it is a ratio of same 2 units, hence it's a dimensionless quantity. So what is given here is basically the reference substance for the liquid is commonly taken as a water. Thus, the specific gravity of a ratio of density to the substance in a question to the density of water. Means if in our question a substance is given as a water, that time you have to take a specific gravity of a substance with respect to the density of water, right? The specific gravity of gases frequently referred to air. Sometimes what happens, all the time liquids will not be given. Sometimes gases also would be given. If gases are there in the question, that time reference substance also would be used gas, and that is nothing but the air. Okay, but it may be referred to the other gases. Example, hydrogen, right? And when hydrogen would be there as a gas for the reference standard, then its molecular mass would be taken as a density of hydrogen. As we know that atomic mass of hydrogen is 1. So molecular mass of hydrogen would be what? Its molecule consists how many atoms? 2. So 1 plus 1 has become 2. So in vapor density, right? Vapor density of gas, that is nothing but a density of gas should be divided by molecular mass of hydrogen. Understand? Yes or no? And it has a connection with your molecular formula. Understand? It has a connection with your molecular formula. What you come to know here? Vapor density. Please write down somewhere in the corner. Vapor density is equal to, right, density of gas with respect to density of hydrogen. That is nothing but density of gas with respect to the molecular weight of hydrogen. Because density of hydrogen is nothing but the molecular weight of hydrogen, which is equal to 2. So density of gas upon 2. This is nothing but what? Vapor density. Okay. So density of this gas, if you have to calculate it, is 2, which is divided in this formula. It goes that side and it multiplied to the vapor density. Now we will move to our current problem where they have given you vapor density. Correct? Shall we move there? You understood this concept or not? Or shall I explain it again?
Understood.
You understood this concept or not? Pritam, are you there? Yes. Just want you understand?
Yes, ma'am.
Okay. So vapor density is equal to what? Density of gas with respect to density of hydrogen gas. Hydrogen gas has how many atoms? 2 atoms. Its molecular mass is 2, and hence we have to divide it by 2. Correct? And this side it is divided. When it moves that side, it becomes multiplied. Fine. Now we'll move to our problem. What we have to see in that. We have learned this, no? We have to go down, I guess. Give me a minute, okay? What is the vapor density given to you? 45, correct? Yes? Tell me, speak up.
Yes, sir.
Jaswant, you are speaking, I guess, but then your mic is mute.
Ma'am, yes. Can you hear me, ma'am?
Yeah, I can hear you. Fine. Yeah. Here you were. Okay, fine. So yeah, this is the problem, right? Which we were solving. Now they have given you what all these terms here. They've given the percentage of carbon, percentage of hydrogen, percentage of oxygen, correct? And that we have seen, right? That all must be 100% totally, right? And the vapor density is given. So we know the relation in between vapor density, right? With a molecular weight. What it would be seen. Density of gas is like a reference density when we calculated with respect to hydrogen gas, then we called it as a vapor density. Means density of this whatever empirical formula they have prepared. Its molecular mass or the density. Molecular mass is equivalent to density. Would be equal to what? With respect to multiplication of vapor density multiplied by 2. Why? Because the density of hydrogen is 2. Already we have seen that formula. So that formula would be what's here. If you wanted to write, you can. Molecular mass is equal to, or molecular weight is equal to, what it would be? 2 into
2 into vapor.
vapor density. Why it is 2 into vapor density? Because we have seen to the vapor density's formula. How we have calculated vapor density? Density of gas upon density of H2, correct? Yes or no? This is what? 2. And density of gas is nothing but your molecular weight or molecular mass, correct?
Yeah.
Yes or no? So molecular mass, this 2 is divided, it goes that side, it becomes multiplied. So by this you can calculate the molecular mass of a compound because they have given you the vapor density. So molecular mass or molecular weight is equal to 2 into 45, which is equal to how much? 90. Correct? Yes or no? What is the answer? 90.
90.
Yes. Now empirical formula you have to calculate. What it is? Empirical formula we haven't calculated directly. We have to calculate with the help of the elements and the percentage. So what you have to do, first of all, you have to take the percentage mass in the column like this. That need to be divided by their atomic masses. For the carbon, it is 12. For hydrogen, it is 1. And for the oxygen, it is 16. When you do so, you will get the ratios over here. Correct? Ratio for the carbon will be what? 26.59 should be divided by 12. Then for the hydrogen, 2.22 should be divided by 1. That answer would be 2.22 directly. And the later it is 71.19 divided by 16. Correct. When you do this, what you will get? These values, correct? 2.216, 2.22, here 4.45. You do this calculation. I hope both of you are able to do that. Right?
Yes,
Yes,
ma'am.
this one, Preetam, can you do the calculations or not?
Yes.
Yes or no? Speak up.
Yes.
Very good. Now, when you do this calculation, you will get this value. Which one is the least value? 2.216.
216.
This value will be divided each of the ratio. That is 2.216 divided by 2.216. It is equal to 1. 2.22 should be divided by 2.216. It is also almost equal to 1. And then 4.45 when divided by 2.216, it is almost double value. So value would be 2. So your empirical formula will be what? Empirical formula will become C1H1O2, correct? Yes or no? This is your empirical formula. Now you have to calculate what?
Molecular.
Empirical formula weight. Correct? That is 12 plus 1 plus 2 into 16. What it will be? Come on.
45.
13 plus 16 to the 32, that is equal to 45. This is empirical formula weight. Now you have a molecular formula weight, empirical formula weight. You can calculate the value of N. N is equal to molecular formula weight or molecular weight upon empirical formula weight, which is equal to 90 upon 45 is equal to N. Correct? Yes? Yes or no? Fine. Now molecular formula is equal to what? N into empirical formula, which is equal to 2 into CHO2. Correct?
Okay.
But what happened? Okay, I have to share it again. My screen sharing has been stopped. Just give me a minute, okay? I'll share it again. It's visible now?
And it's visible.
Fine. So what you have to do, just you have to multiply this empirical formula by 2, you get how many? Now how you're going to write? So this 2 will come as a suffix over here, okay? So how many carbons? This carbon will multiply by 2, so it becomes C2. This 2 again multiply by this hydrogen, it hydrogen become H2. And this oxygen, 2 atoms are there in empirical formula, it multiply by 2, it become O4. Understood? So your molecular formula would be C2H2O4. Means by knowing the vapor density, by knowing the percentage of the element present into the given substance, you are able to calculate empirical formula as well as molecular formula. Understood?
Yeah.
Yes, these both things you can calculate. And that is a beauty of chemistry. Means few things are given and you are able to calculate the many more by that. Okay? Understood? Yes? If any question, any query about it, please ask. Right? Okay, fine. So I have pasted the questions already for you about the molecular formula and empirical formula. I'm going to explain you. But then before that, I have the formula again, which I have explained earlier that you need to write down, which is quite important. If you know this formula, you're able to solve the problems related to this densities. Okay. Shall I give you? Will you write it?
Yes, ma'am.
Yes, ma'am.
Take the page below where is the vacant place. Okay. Write down about densities. Normally density is equal to what? Already I gave you, but then it wasn't in sequence manner. So I'm going to give you again. Write it down any of the page. Density is equal to mass upon volume. This is a basic formula to calculate the density. I think I need not to give a unit, but then honestly, if you forget at any time, you can write it. Unit for this would be gram per centimeter cube. Cubic centimeter also you can say cc. Then next one is relative density. Relative density would be density of any substance with respect to density of a reference substance. Then the specific gravity. Specific gravity is equal to density of any substance upon density of water. Okay, and this is for what? Liquid state. Keep it in your mind. Density of water, and density of water is always considered at 4 degrees Celsius. Why it is? Why at 4 degrees Celsius? Do you know? Huh? It's the anomalous temperature for the water, correct? Anomalous behavior of water about the densities you have heard or not at the 4 degrees Celsius. If not, then please refer once. It's important. You might have learned it in your grade 8 or 9. Correct? In physics also you might have learned, not only in chemistry. Correct, Jaswant? And lastly, vapor density. Vapor density with respect to gas, right? Your density of any substance with respect to density of hydrogen. Right? For the like vapor density, I will give you a few more things. Have you written that? This up to vapor density you have written? Jaswant, you wrote? If yes, please show thumb if you can't speak. Yeah. Pritam, you wrote?
Yeah.
We just go little down and I'll give you a few more things about the vapor density right now. Vapor density is equal to that will be density of vapor at some temperature and pressure. Because a few more problems would be asked to you. In that case, density will be given at the particular pressure and the particular temperature. So that is also need to be considered, because all the time it cannot be STP. It can't be standard temperature and pressure. It can be normal pressure temperature as well. So that values we need to take in the formula. And hence that time this formula you need to use. Density and the vapor at some temperature and pressure divided to density of H2 at same temperature, means whatever temperature would be given here, some temperature, at that same temperature and pressure, density of water you need, hydrogen you have to take. Okay. And another relation in between vapor density and molecular formula would be vapor density is equal to what? Molecular mass of a substance with respect to molecular mass of hydrogen which is equal to molecular mass upon 2. This is a vapor density. Clear? Understood?
Yes, ma'am.
I hope both of you have written.
Yes, ma'am.
Because it's very, very important. Okay. Many more questions already I gave you in your test. Please go and try to solve. If you can't solve, in tomorrow's period, I will solve all those 5 questions because that is important. They have three different densities at the different temperature and pressure. How to calculate molecular mass and how to calculate this one. What we can say. Empirical formula by knowing the different things that we are going to see, because number of problems would ask on it. Fine. Okay. I'll post one or two homework questions as well that you need to write down. It's all formally you have to write whichever formula I gave you today once again. Okay, and the post back me into the assessment. Okay. Pritam, just one.
Yes, ma'am.
Okay, fine. No issues. So shall I end the class?
Okay, ma'am.
Yeah.
Yes, ma'am.
Okay.
And though today by mistake it happened, I have posed the timing 6:45, but then everyday timing the same, that is 5:45. If somebody has been not posted, then you have to be consider it as a 5:45 only. Okay, and for today I'm extremely sorry for that. Shall I
Okay.
end the class?
And thank. Bye, ma'am.
Yeah. Bye. Take care.